When I started working on Aosp, my first try was not that much successful. There were lots of things that I was not aware of that. For example, it was not easy to find the location of the packages. It was not easy to find the build system problems. And of course, even if you start from scratch and building Aosp, usually there might be some problems. They might be relating to repos, they might be relating to some packages or lacking of some required libraries in your system to build it successfully. I went through lots of courses, documents, and videos, but unfortunately there was not that much integrated and clear information as a roadmap to follow and getting to what I wanted or what I was looking for. Hello and welcome to my channel. My name is Mohammed. I am going to Hello and welcome to my channel. My name is Mohammed. I'm going to provide some videos, which this one is from Hello and welcome to my channel. My name is Mohammed. I'm going to provide some videos which will help you to understand the Aosp and its architecture easier and quicker. In this video, I will try to explain the abstract layers in Android, and we will go through one practical example, which is Vibrator from Aosp code, and see how it works from the application layer to the HAL layer. Let's look into Android abstract layers and discuss about their functionalities and responsibilities and about a little bit about their characteristics. The first thing which I would like to clarify here, we don't have really these layers in Android. Actually, they are abstract layers that you're assuming that they are there based on the responsibilities and the boundaries that somehow clarifying the responsibilities of each part of Android, or maybe the processes that are running within Android to have a better understanding. It's good to categorize the applications and services in some abstract ways to have some boundaries between them. Uh, there are different diagrams that you can find for Android. For example, something that usually Google using in its Google Documents. But here I have tried to provide almost 7 layers. The first layer is application layer. Then we have Android framework. The next one is system services, Android runtime, which I mean intentionally added here. Then we have HAL layer, the last layer of Android on top of kernel demos and native system services, and the last one will be kernel. We have 7 layers. You can find different number of layers that people has been defined within Android. But the point is, if you know that they are abstract, there won't be that much, I think, argument anymore. In application layer, we are dealing with 3 different type of applications. The first one is normal apps, then privileged apps, and the last one is system apps. The normal apps are the applications that we are usually developing and publishing through Play Store, but of course, the Play Store could include privileged applications as well. System apps are the applications coming by Aosp code mainly, and the privileged apps are the applications that developed by vendor. And there's a point about privileged applications. Usually, we have bundle and unbundle apps that we can include an application as a pre-built or built with a source code with Aosp, but there is another way that we can put a footprint of application, which we call it stop, into Aosp image, and later we can install some applications with the same footprint and with the same signing key into Aosp, and these applications, based on their configuration within Aosp, could access to system APIs or vendor specific functionality and APIs. So they will work as a system service, system applications with the same privilege and permissions that they have defined for. And the next layer, which is Android frameworks, including APIs, classes, even interfaces, and some precompiled code. And as you know, APIs comes into two different categories: public and system. The public one, which is the APIs that you can use in your normal applications. It's not required to have any stop or being signed with the system signing key, but the system APIs are the ones that you need to build your application with the Aosp or having a stop there. There are OEM specific, which they are defined, but OEM are vendors and they are not part of the Google source code. The next layer is system services. System services are essential services that providing the functionalities through APIs. And there is an important maybe topic here, which we call IPC mechanisms. Android framework using IPC mechanisms, which is mainly AIDL here, to get services from system services. Actually, the APIs that we are calling or using from Android framework will happen through an AIDL interface between the framework, which is part of our application when we are building, and system services that are running in the background as a system services. There are other videos that you can watch in my channel about IPC mechanisms. The next layer, which I intentionally added here, is Android runtime. The point is, till here, everything is based on Android runtime. We might develop them by Java, Kotlin, or C++, but they will run within or on top of Android runtime, which the previous version was Dalvik, and the new version for a long time is Art, which is translating our application bytecode into processor specific instructions. I've added Android runtime to show you that um, on top of above the Android runtime, we have Android framework and Android environment, but the lower layer are more into the native development. We have a HAL layer, which is an abstraction layer. It doesn't exist at all as something that you can find within the code, but there is a concept that we'll explain later. The next layer is daemon and system services, which we are discussing about native applications, native libraries, and that they directly interact with kernel through some APIs. And the last one, which is Linux kernel. So here we discuss about 7 abstract layers within Androids. There's one thing which I would like to explain here. As I mentioned, we have IPC mechanism within Android between the system services and the native demos and native system services um, to communicate and sending or receiving data or invoking some functionality within an IPC mechanism, which will be AIDL, or for the legacy code, it could be HIDL as well. Here we had a look at the layers quickly and explain how they are working and communicating. I have provided another diagram here with some examples. For example, in application layer, you can see contacts, phone, camera, browser, or map, and etc. As of some as an examples of normal system or privilege applications. And in framework, I have explained I have showed some managers like activity manager, location manager, and so on. And they are some corresponding system services for each part of Android framework. For example, when we discuss about activity manager, the activity manager classes will communicate with activity manager service. Window manager will communicate with window manager service, and so on. For each services, each system services, we have some classes within Android framework. The next layer, which is about Android runtime and some native libraries. The reason to splitting this part into two different categories is the reality. Actually, in reality, we might have Android runtimes, but for some reasons, there are some libraries provided with native codes that we might communicate with them directly. So I didn't want to make a confusion. So here you can see that the system services could communicate with some other services as well while they are running on top of Android runtime. The next layer is the HAL layer, which you can see I have put some examples here like audio, Bluetooth, Wi-Fi, and graphic. But again, we need to know that the native libraries might communicate directly to the kernel functionalities, and it might not happen through HAL layer. This abstract diagram is showing that the abstract layers might not exactly work as the first diagram that I showed. Usually the abstract layers simplify to show the concepts, but they are not reflecting how exactly the processes and the layers are working together. In the next session, the next step, I will show you how Vibrator works from the application layer to the HAL layer, which will help you to have a better understanding. It will be a quick review, but it will help a lot to understand how it works. I think now that's a good time to discuss a bit about a practical example within Android to understand how it works from application layer all the way down to the kernel. We discuss about abstract layers, each layer responsibilities and functionalities, also a bit about how the layers are communicating together. I have decided to discuss about the vibrator, which is almost not that much complicated example within Android. I don't want to make a complicated example because then I needed to explain a lot about other topics. But Vibrator is kind of a separate functionality within Android that without having any knowledge about the other parts, we can discuss here a bit. First of all, I would like to show you this diagram, which we saw in the um, previous discussion. Just think that we have an application here on top of the Android SDK, and what we want to do is to using the Vibrator APIs, which is part of Android SDK. So what's going to happen here is uh, the communication between application and Android SDK is totally direct. Somehow the Android SDK will be embedded into our application, so there is no communication in place. But between Android SDK and system services, there is a bit complexity. And that's something that I would like to add it here, which is an AIDL interface, which we discuss a bit as a communication way between, as IPC mechanism between different processes. The point here is that our application will run as a separate process, and Android SDK will be embedded into our application. What we need to do is to getting, let's say that invoking a function from a sister service, which is Vibrator or Vibrator Manager. So this service is a separate service. So it's clear that now we need to have a mechanism, an IPC mechanism. And this IPC mechanism here is AIDL specifically for the vibrator. So here is the first part, or maybe the first communication, the first AIDL communication is happening between Android framework and system services. This system service, which we will discuss and I will show you later, is a Java base. It's an Android service, which has been developed with Java. So, and it's running as a system service, a separate system service. So it's clear that we need to have an AIDL interface in place. Then this system service, based on our request, what we are invoking, which method we are calling, needs to call an appropriate method from the HAL layer, which is running as a native demo. So the second place that we need to have an AIDL interface in place is between system service, which is an Android service, and a native daemon, which is running as a vibrator service. What I need to explain here is, here the system service is Android based. Based on the let's say that it's running in Android within Android runtime, and our application as well. But this daemon is a C++ code, and again there is a communication IPC communication. So now we know that what we are expecting to see within Android as a diagram. Let me show you another diagram which I have tried to provide with Plant UML here, which has a bit of maybe detail about what's happening there. So in the at the top of the diagram, what we can see is our application, which is running as app code. And just think that we are finding or getting a handler from this system service, which we are willing to invoke its methods. Based on the Android version that we are working with, it will end up to a vibrator or vibrator manager, which both of them are part of Android framework that you can find in this place within Aosp code. And I have selected exactly the Android 15 as an example. Let's say um, that I have found these files within Android 15, but in the lower versions, you might, or maybe older versions, you might find these files and classes in other places, a bit different, but not that much. So uh, here we have two different AIDL service, iVibrator service.AIDL and iVibrator Manager service.AIDL. The second one is new in a newer version of Android. I think it's after API version 31st, which we need to get a handler here or find a service which is Vibrator Manager, but previously it was just the Vibrator or Vibrator service. But now the second one is something that after API 31st you need to work on. So here you see that we have a communication, AIDL communication in place, which is here. between our application and framework and this part, which is a system service. And here is the name of the class of the Vibrator Manager service, which is part of Android 15. Of course, there are other classes that helping to provide the functionalities, but having a quick look is that our application is using framework, and framework is utilizing this AIDL to communicate with the Vibrator Manager service. But that's not the end of the story, because we need to communicate with an implementation of the vendor, which is in C++. And this path that you can see here is a bit old, which I couldn't find any example from Pixel. I think in the previous version of the Android was there, which I used, but there's another example of a vibrator implementation that I will show you later in some minutes, that you can see how it works. So the service need to invoke something from a native process, which it will happen through iVibrator.aid. For information, in Android layer, which is here, application layer, framework, and system service, the IPC mechanism is usually AIDL. But between system service and the HAL layer, it could be HIDL or AIDL, which is in this example AIDL. And there is another step, which is getting service from the native code within kernel. Here I have another diagram with more detail, which I can show you again here. I'm not sure, maybe it might be a bit more like, I don't know, to me it's more interesting because it has more details and more information. For example, here I've mentioned that the application needs to have a specific permission, which is Android permission vibrate. And based on the Android version, you might use Vibrator or Vibrator Manager. You can see that here you can find two different paths. One of them will end up to the Vibrator Manager. Another one, which is an older version of Android, as I mentioned, it ends up to Vibrator.java, which is framework. Then there's an ideal interface again, and system services. Then we have a HAL interface, but here there is more information about what we are discussing here. For example, here we have Vibrator .cpp, which I will show you later, Vibrator Manager. There is a RC file which will help to initiate this daemon, this native daemon within AISUet after booting or as a part of booting it. And then it shows how it calling the system services from the kernel. So now we have an understanding that how this communication is happening, and what we need to do now is to jump into a bit of Google documentation, and I would like to navigate a bit in Android Studio as well. Well, here what we have is a vibrator from Google Documents that you can see here. It's a vibrator, you can see it was available from API version 1, and there are some information that you can find how it works. But what I would like to explain or mention here is that from API level 26, this vibrate is deprecated, and we need to use something else as well, which is part of another package name. Here it's mentioned what kind of permission we need to use the vibrate method. Nothing special here to discuss more, but there are some other changes for API level 33 and others. And again, you can find Vibrator Manager here, which was introduced in API level 31st, which I mentioned in the diagram. And here you can see different methods that it's providing. For example, the vibrate is here, which instead of using the deprecated versions, we need to use Vibrator Manager. There are other API references like context. For example, if I search vibrate or maybe vibrate, if I'm not wrong, here it will end up to Vibrator service, which as you can see here, after API 31st, we need to use something else as well. So we cannot cast it to Vibrator, and we need to cast it to Vibrator Manager instead, which is something which I think I showed you here. Just for the information, yeah. Let's jump into something else which I was um, looking for, within Aosp code. As you can see here, the version which I am showing you is Android 15. And here's the release version that you can find what exactly I'm trying to show you. Here we have Vibrator class, which is an abstract class that somewhere else it's been implemented. Just for your information, there are lots of abstract maybe functions. Sorry, not abstract functions, some functions that need to be overridden later. For example, here you can check the get default vibration intensity, or maybe we can find you can find out if the has vibrator has been implemented. But as you can see, it's an abstract function that should be implemented somewhere else. Having a look at vibration manager would be something else that we can discuss about that. Let's look into vibrator manager. Again, it's an abstract class like the vibrator, and it's providing almost the same functionality, but a bit in a different way. For instance, if I want, I'm looking for something specific here. You can see this vibrate, which you can make a vibration here. And it's mentioned here that this permission should be part of the Android manifest to work. You can look into that more, or maybe in the future I can provide another video and discuss in detail about vibrator. So let's jump into framework, which I mentioned there. Here we have a package, which is Android OS Vibrator, which I showed you here as well. It's part of, sorry, I think that would be here. Yes, Android OS Vibrator, which I discussed there, and this one, Android OS Vibrator, that's the same package within framework, which is providing different classes. It has for example, an AIDL interface, somehow an AIDL interface here, which you can see that it's providing different functionalities and methods that they should be implemented within the service. And here is another one. And here we have the service version, the system service, which I mentioned previously. For example, vibration.java. Let's look into vibration Java as well. For example, we have vibrator controller. We have vibrator manager service. Maybe vibrator manager service would be more interesting for us because that's a service extended from iVibrator manager service, which is a stop, because this one is an AIDL interface, which we can find it and see what methods has been defined within that. To do it, I have found the iVibrator manager service. Let's look into that. It's an interface. It's an AIDL interface. Of course, that's something that from framework we will use this AIDL interface to communicate with vibrator manager service. So, for example, is vibrating. It means that is it in a vibration mode, and some other classes that you can see here. Of course, there are other things that we can look into them. I think that's good to not going deeper for now, because then we need to explain different part of this service. It's not a big service, but there are lots of details that we can discuss. So the next step, which I wanted to mention here, is an vibration or maybe vibrator example. This in this Android blueprint, what you can see is a example service, which is a C++ service. And as you can see here, there is an AIDL interface, which is mentioned here. This is Android hardware vibrator version 3 NDK is a library from AIDL, from my understanding. So, which if I make another video, I can explain about that as well. Here we have some services, but to show you that which file is the start point, here is we have a main CPP, which if we come here, what you see is a binder that adding a service, and the other part is, or I mean the other steps happening here. But let me make an example here. We have a vibration manager, which would be a good point to start, but I know that we have another class as well. So we have two implementation, vibrator and vibrator manager. For example, we can look into vibrator service, and here what I'm more interested to show you here. Wait, to open the header file. Here you can see there is a BN vibrator. A BN vibrator is a header file generated from an AIDL interface. And we need to inherit and implement that in a vibrator. And there are some methods that we can call them. So if we open iVibrator, we will see how, all these methods defined in an AIDL interface, and that's the same thing happening for vibrator manager here. You can see cancel sync, prepare sync, get capabilities. Maybe I can quickly check if that's a same one. Not this one. I think we are discussing about, okay, yes, that's a iVibrator manager service, which is a different one. And we have iVibrator manager.aidl, which is a different one, which I think I can find maybe here. Yes, in a default version. We can see how it's implemented. It's the current one. Yeah. So we have all the things we need here. For example, iVibrator manager, which I mentioned, which I said that's here. Here we have all the interface. For example, prepare sync. Let's find that. Yeah, that's here. Or maybe a start session that I think it would be here as well. Yes, a start session. So that's the AIDL interface we are implementing here. And the point is that this service, this iVibrator manager, will be used by the system service as well to get services, or maybe invoking something from the HAL service, and the HAL service is invoking the kernel functions which has been provided through a device a device driver. So that's how it looks like. I'm not sure if that's interesting, but let's look into that. Here you can see that we have get system service, for example, from Android S. I'm using this part of the code, which instead of looking for vibrator service, I will ask for vibrator manager service, which is a new version, and I need to cast it to vibrator manager. So that's how it works. or maybe in the previous versions of Android, I need to cast it to Vibrator. As an example, if I want to be more specific here, you can click here that you will end up into this class. The point is, as I showed you in the framework, this Vibrator manages an abstract class. Or maybe in the helper, I can use this vibrator, which will be the same as well, but they have been implemented somewhere else. Anyway, here we have seen how the vibrator is working. I think it was cool to have a better insight with a practical, a real example from Aosp. Hope you have found this video useful and you have a better insight into Aosp code. Thank you for watching and see you in the next one.